Solar energy technologies and power plants do not produce air pollution or greenhouse gases when operating. Using solar energy can have a positive indirect effect on the environment when solar energy replaces or reduces the use of other energy sources that have larger effects on the environment. But is solar energy completely climate-friendly? Solar energy technologies require use of materials such as metals and glass that are energy-intensive to make. The environmental issues related to the production of these materials could be associated with solar energy systems when conducting life cycle or so-called cradle-to-grave environmental analysis. Studies conducted by a number of organizations and researchers have concluded that PV systems can produce the equivalent amount of energy that was used to manufacture the systems within 1 to 4 years. Most PV systems have operating lives of up to 30 years or more. There are hazardous chemicals used to make photovoltaic or PV cells and panels that must be carefully handled to avoid release to the environment. Some types of PV cell technologies use heavy metals, and these types of cells and PV panels may require special handling when they reach the end of their useful life. Some solar thermal systems use potentially hazardous fluids to transfer heat, and leaks of these materials could be harmful to the environment. U.S. environmental laws regulate the use and disposal of hazardous materials. The U.S. Department of Energy is supporting various efforts to address end-of-life issues related to solar energy technologies, including the recovery and recycling of the materials used to manufacture PV cells and panels. Several states have enacted laws that encourage recycling of PV panels. As with any type of power plant, large solar power plants can affect the environment at or near their locations. Clearing land for construction and the placement of the power plant may have long-term effects on the habitats of native plants and animals. However, installing solar energy systems on land with marginal agricultural value or integrating solar energy systems on farms may provide a variety of economic and environmental benefits to farmers. Some solar power plants may require water for cleaning solar collectors and concentrators or for cooling turbine generators. Using large volumes of groundwater or surface water for cleaning collectors in some arid locations may affect the ecosystems that depend on these water resources. In addition, the beam of concentrated sunlight a solar power tower creates can kill birds and insects that fly into the beam. The traditional process of manufacturing a solar panel begins with quartz, a very common mineral that can be found right in your home if you have granite countertops. Composed of oxygen and silicon atoms, researchers discovered that this mineral can be converted into pure silicon for use as a semiconductor in solar panels to generate electricity. Solar manufacturers historically mined quartz to supply the silicon for their solar panels. However, the mining of quartz crystals exposes miners to silicosis, a lung disease caused by inhaling tiny bits of silica from the ore. As a result, the solar industry is gradually moving away from quartz mining and towards quartz-rich sand. In order to make metallurgical-grade silicon usable for capturing light, that quartz-rich sand must first be converted to polysilicon, which is another form of silicon with a different atomic structure. The chemical reaction that creates polysilicon produces a byproduct called silicon tetrachloride. If it isn't disposed of properly, that new chemical can cause soil acidification and emit harmful fumes. Thankfully, scientists figured out how to recycle silicon tetrachloride back into polysilicon and reuse it in the production of even more solar panels. Still, researchers continually look to improve this process and make it even more sustainable. In China, where a growing portion of solar panels are made, there are set regulations for manufacturers to recycle at least 98.5% of silicon tetrachloride waste. Moreover, scientists at the National Renewable Energy Laboratory, a division of the U.S. Department of Energy, are experimenting with alternative production methods that can avoid silicon tetrachloride altogether. With any luck, both of these strategies will result in a substantial reduction of waste, which will increase the stature of solar power as an eco-friendly source of power. Do solar panels leave carbon footprints? Electricity produced from solar yields no emissions, no greenhouse gases, and no fossil fuels, but it does require a certain amount of energy to make the solar panels. Luckily, the energy they produce far exceeds what it takes to manufacture them. The solar power industry pays attention to these details by actively seeking ways to improve this power imbalance. In fact, researchers created a metric called Energy Payback Time, or EPBT, to measure the length of time it takes a solar panel to generate the amount of energy equal to what it took to be created. For multi-crystalline silicon systems, i.e. solar panels, it currently takes 4 years to achieve EPBT, according to the US Department of Energy. Since solar panels last for 20 to 30 years, a single solar panel can generate more than 4 or 5 times the energy used to produce it. Like and share the video with your friends, and don't forget to subscribe. Ring the notifications bell to also stay tuned to the channel.